Okay, so we'll be looking at chapter 2. Chapter 2 includes accuracy. Okay, in accuracy, we'll be looking at approximation, estimation, and upper bound and lower bound. Okay, so in this chapter, these are the things we're going to cover. We're going to cover estimation, approximations, and upper bound and lower bound. First of all, when you talk about accuracy, you definitely refer to your upper bound and lower bound of estimation. Okay, so we definitely refer to our upper bound and lower bound of estimation. Now let's quickly take a look at approximation. We start with the first one, which is approximation. Okay, so we start with the first one, which is approximation. And when do we normally use approximations? Approximation is for us to find a close value for a particular number. Okay, a close value of a particular number after we've done our arithmetic. After we've done every arithmetic, whatever answer we find, we can now find the close value to the nearest whatever number they want us to do. So the nearest, maybe nearest 10, nearest 100, nearest 1000, whatever it is, which will take us to rounding. In approximation, we have different techniques to approximate a number. We have up to like 3-4 techniques of approximating a number. The first one is rounding. The first technique for approximating a number is rounding. The second technique is significant figure. The third one is decimal places. Okay, so we have these 3 methods of approximating a number. The first one is rounding. Most of us were very familiar with rounding. Second one is significant figure. So I just write SF, significant figure. Okay, how many significant figure they want us to do it approximate the number. The third method we use for approximation is called decimal places. It's called decimal places. Decimal places, DP. So maybe 2 DP, 3 DP, 2 decimal places, and so on and so on. So these are the 3 methods we normally use for approximation. So approximation is the arithmetic we do by taking a number to the nearest number we want it to be, or nearest whole number, after we've done our calculation. So remember, approximation is after your calculation. After your calculation. Estimation is before your calculation. Okay, so now let's quickly move on to the first method, which is rounding. Now in rounding, for example, if we give it this number, we're going to round this number to the nearest 10. We can round the number to nearest 10, nearest 100, nearest 1,000, nearest 10,000, and so on and so forth. Okay, nearest 100,000, and so on. It depends on the examiner how many places he wants us to round, or how he wants us to round the given number. For example, we're giving this number 28,617, and they want us to round it to the nearest 10. They want us to round it to the nearest 10. In rounding, we start from the right, and we do the number to the left. We start counting from the right, and we move to the left. Now, what we do here is that we start counting. If they say round it to the nearest 10, we're going to count 10 has 1 0. 10 has 1 0. So we're going to count this number only once from the right. We're going to count it only once from the right. And then we break it. We break it. We count it only once from the right. We break the number. We break it from there because 10 has 1 0. If they say nearest 100, we would have counted twice. 1, 2. And would have broken it from here between 1 and 6. But they say nearest 10. 10 has 1 0, so we do only one counting, and then we break the number. Then in rounding, one thing you need to know, number between 5 to 9, we round them up. We say round up. You take them as 1. Round them up means take it as 1. Okay? Numbers between 1 to 4, you round them down. Round down means take it as 0. Meaning just write it as 0. Write it as 0. Okay? So this is round up. So I'll just write round up, arrow U. Okay? This is round up, arrow U. And this is round down, arrow D. Round down, arrow D. Okay, numbers 1 to 4, we round down. We round them down, meaning you just replace with 0. Now, which number do you consider for the which number do we give this consideration to? It's the number on the right. The number on the right. Okay? When we break it down, when we put a broken line here, the number in our rightmost side is the number we are giving that specific consideration to. So now take a look at it. You check this number. If the number is between 5 to 9, 7. So remember I said take it as 1. So what do? You take this number as 1. Okay, you take it as 1 and add the 1 to this one. Take it as 1, add it here. So here becomes 2. 1 plus 1 is 2. This one, that after you take 1, you have to write that place spot as 0. Write it as 0. The every other number remains as it is. This 6 remains as it is. This 8 remains as it is. And these 2 remain as it is. So we've rounded this number to the nearest 10. So it becomes 28,620. The original number is 28,617. When you round to the nearest 10, it becomes 28,620. Okay? This 17 is rounded to 20. It's rounded to 20. So that's to the nearest 10. That's the first one, the A part of this question. Now let's take a look at the B part of this question. The B part of this question says we should round that same number to the nearest 100. That same number, 28,617, we should round it to the nearest 100. So since the same number has been given to us, we do the same thing that we've done just now, but in this scenario, 100 has 2 zeros. So we're going to start counting from the right two times. 100 has 2 zeros. So when we are counting, we're going to be counting from the right twice. We're going to be counting from the right twice. So I'm going to count from here twice because 100 has 2 zeros. 1 and then 2. Then before I break it from here. Okay, because 100 has 2 zeros. We're going to break the number from here. We're going to break the number from here. Now, you see the number on the right, which is nearest to the number where we broke. You're going to consider that number to round up or to round down. So the number is 1 in this regard. So are we going to round up? You check. Why? What's the condition for rounding up or rounding down? We say number 1 to 4 is round down, meaning just write it as 0. You cannot take 1 and move to anywhere. So write this 1 as 0. Similarly, you have to write this 7 as 0 because the consideration for the number is the number right just beside the broken line we've drawn. Okay? Then you write 6 as it is, and then you write 8 as it is, and you write 2 as it is. So you've succeeded in rounding this number to the nearest 100. Okay? Now let's do the C. Round the same number to the nearest 1,000. Round the same number to the nearest 1,000. So we write the same number. We say 28,617. 28,617. We go to round it to the nearest 1,000. 1,000 has how many zeros? Has 3 zeros. So since 1,000 has 3 zeros, we go to round this number. 1,000 has 3 zeros. So we go to count 3 times from the right. We're going to be counting 3 times from the right. Okay? We're going to be counting 3 times from the right. Now let's count 3 times from the right. 1,000 has 3 zeros. 1, 2, and 3. So I always put small arrow here to show that I'm coming from the right to the left. So I break it from here, I break it down after counting 3 because 1,000 has 3 zeros. So I break it down here. Once we break it like this, then we check the number rightmost to the broken line. The number rightmost, and the number is 6. Now you check here, you see your round up. Number between 5 to 9, you round up. So I'm going to take 1. When we say round up means take 1 from it. So take 1 from here, add it to the next number behind on the left. So I take 1 from this 6, I add it to this number, it becomes 9. It becomes 9. Every other number on the right will eventually turn to 0. Remember that. Once you take 1 from here, every other number turns to 0. Okay? Every other number on the right, every position of it, you write 0 for it. This 8 has become 9, and this 2 you write here. So now this number becomes 29,000. This number becomes 29. So if you round this one to the nearest, you know why? 670 is closer to 1,000 than it's closer to the nearest 1,000 than where it's coming from. Because you pass the boundary halfway of this number. So that's why you add 1 here, becomes 29,000. Now let's do the same number. Let's do it to the nearest 10,000. That same number, Let's do it to the nearest 10,000. 28,617. 28,617. Let's do it to the nearest 10,000. Let's round it up to the nearest 10,000. Okay? Let's round this number to the nearest 10,000. Now, when we do that, we go to count 10,000. You check how many zeros does 10,000 has? 4. 10,000 has 4 zeros. Since 10,000 has 4 zeros, we go to count 4 times this number. We go to count 4 times. Okay, we go to count 4 times. We start from here, we count 4 times. 1, 2, 3, 4. So we go to break it from here. We go to put the broken line here. We go to put the broken line here. So you break it from here, and then the next thing to do, you see this number, you check whether you can, the rightmost number to the broken line, you find out whether you can round it up or you round it down. Now you look at your round up condition. Number between 5 to 9, you round them up. Number between 1 to 4, you round them down. So what it signifies is that we can simply round up this 8, right? So we take 8, put here, it becomes 3. If you take 1 from 8, you put in 2, it becomes 3. The every other number on the right will become 0. So this will become 30,000. This will become 30,000. Okay, so this is how we do rounding. So the next one we're going, you have a lot of questions for you to practice. It's a round this following number to the nearest 1,000. So round this one to 1,000. You count 3 times. 1, 2, 3. So you break from here. So you take 1 from 7, put here, it becomes 69,000. If you round to the nearest 1,000, this number will become 69,000. This number will become 69,000. If you round to the nearest 1,000, right? This number will become 69,000. So if you round this one to the nearest 1,000, you count 1, 2, 3. This one will become 4,000. This one will become 4,000. Because this 0, you cannot approximate. You cannot round it up. You just write as 0. Finish. This one will become 4,000. So there are many questions for you to try and practice. Okay, this one, round to the nearest 1,000, you count. Count 9999. Yes, this one is very good for practice. 1, 2, 3. So you break from here. You break from here. Now you take 1 here, because here you can round up. Take 1 here, put here. This one become 10. So you're not going to write 10. You write 0 also. Okay? You carry 1, put here again. This becomes 10. You write 0. You carry 1, put here. This one, the last one becomes 10. Is the last one you write 10. Is the last number you write 10, because you don't have anywhere to carry 1 to. Then the ones on the right, you write all of them as 0. The ones on the right, you write all of them as 0. There are 3-digit number on the right, so you write them as 0. So this becomes 1,000,000. 999,999 has become 1,000,000 when you round it up to the nearest 1,000. Okay? So with this, I think we are good now with rounding up. We're good with rounding. So we go to the nearest one, which is called decimal places. Let's go to the nearest one, which is called decimal places, DP. Okay? Decimal places is this one. We're counting, both this one significant figure will be counting from the left to the right. You know, rounding, we are counting from the right to the left. This one will be counting from the left to the right. But however, because they call it decimal place, this one will start counting from the decimal point. For example, they've given us 7.864. 7.864. So this one we go to, they say round it up to the nearest 1 DP, 1 decimal place. Round it up to the nearest 1 decimal place. Okay? Round it up to the nearest 1 DP. Round this one up to the nearest. We're going to do it to 1 DP, 2 DP, and probably 3 DP. Okay, or 1 and 2 DP. Let's do A. We call this one A. So to 1 DP, meaning you start counting from your decimal place. That's why they call it decimal point. This one you start counting from your decimal place. You count from here to here. That's why they call it DP. You count only once. So you break from here. You break this one from here. Okay? You break this one from here. And this number you see you can round up. Take 1 here, put here. This answer becomes 7.9 only. In decimal place, you don't add zeros. You don't start adding zeros. You don't turn this one to 0, this one to 0. You don't write the zeros. It doesn't make sense after decimal writing zeros in front of it. okay, in mathematics. So you just write 7.9 to 1 dp. Okay, the B part of the question is that the same number, when it's given to us, they say round this number 7.864 to 2 dp. Okay, after this one, we go to significant figure. Okay, 2 examples is enough for you to grab this. Okay, now after this one, we see this one, right, to 2 dp. To 2 dp, what are you going to do? We're going to count twice. From the decimal point, count to the right. 1, 2. Then you break it from here. You break it from here. Break it from here. Put the breaking from here. And see this number. Can you approximate this one? Can you take it where 1 here? No. This one, you cannot. So you write 7.86 only. You write 7.86 only. Why? Because this 4, we cannot take 1 from here to add to this one to make it 7. So it's just going to be 7.86. This one is 4. It's rounded down. And you don't put 0 in decimal place. You don't carry this one and put it as 0. Okay? So I think that's what we have for decimal. Now let's go to significant figure. The third one. Significant figure. Okay? Significant figure, we also start in this one. The number can be decimal, it can be in whole numbers. For example, if it's in whole numbers, we write the zeros. If it's in decimal place, you don't need to write the zeros. For example, let's say you are given 43.25. 43.25. You're given 43.25. Now they're asking you to round it up to the nearest, to 3 significant figure. They want us to do this one to 3 significant figure. Now the difference between this one and decimal places is that in decimal place you start from the decimal point. But significant figure, you start from all the way from the beginning, the left side. You start from the left, start counting from the left side. Okay? We start counting from the left side. We start counting from the left side. Okay? Let's count from the left side. Now you count from here. 1, 2, 3. So here you can see that you can take 1 from here. You break it from here. After counting 3, because they say to 3 significant figure, after breaking it from here, you can take 1 from here, add to this one. So this will be 3, and then this point will be here, and this 3 will be here, and this 4 will be here. It becomes 43.3. You don't write the 0 because there's a decimal in it. If there was no decimal, you can write this 0 down. If there's no decimal in the number, you write the 0 down. Okay? So let's take a number. Let's look for a number. Let's say, okay, another one. Let's say this is A. Another one. Let's say we have the B 0. We'll give you a number like this: 0.4, 0.0043. Okay, we'll give you this number 0.0043. And they ask us to do it to 1 significant figure. Only 1 significant figure. Okay? Now this one is different. It's quite different. So you pay attention. This one is quite different. Now why? Why is it different a little bit? Because I'm supposed to count from here. Only once. This is 1 significant figure. But 0 is not significant. So I will keep moving till I reach a significant number. I'll keep moving till I reach a significant number. I'll keep moving till I reach a significant number. This 0 is not significant. This 0 is not significant. This 0 is not significant till I reach this number 4. 4 is the first significant number. They call it significant figure. 4 is the first significant number. So you cannot approximate. You cannot take 1 here to add here. So your answer will become 0.004. Your answer will become 0.004. Okay, for this significant figure. For 1 significant figure, if you ask it. Now, what if you are given number? Now, let's try another number that do not have decimal for significant figure. Let's say you are given 4,325. Now, no 0. Do it to the nearest 2 significant figure, 2SF. If you are given a number like this, do it to 2SF. What should we do if we are given a number like this to do it to 2 significant figure? Okay, what we do is that we start counting from the left to the right. So we count from the left to the right. This is what we're going to do. in counting from the left to the right, you count 2 times. 1, 2. So you break it from here. You do the breaking from here. You break it from here. Now you see the number next to it, 2. You cannot take 1 here to put here. So you only have 434300. This one, why do we, just now we didn't put 0 because there was decimal, I said. This one, there's no decimal. You have to add the 00. Because what it makes sense, because you are saying 4,325 is to 2 significant figure, it becomes 4,300. That's what it means to 2 significant figure. If you skip this 2 0, this one will become 43. 43, what's the relationship between 43 and 4,325? You understand? Okay, so this is the logic. Okay, this is the logic why if there's no decimal point, you have to add the 0. Now let's move on to estimation. Estimation is different. You know, the first 3 we've done, they are for approximation. Approximation is rounding, significant figure, and decimal places. We're done with that. The next one is estimation. For estimation, we just round each number to the nearest digit before calculation. This is, you know, approximation is after calculation, but estimation is before calculation. Before you do any calculation, then you have to do this one. Each number, 246. Let's say this is 246. Let's assume this is 246. You are asked to multiply this. They say estimate the answer. So you can estimate this one first, estimate this one first, before you now do the final answer. Okay, I can, one significant figure, I'll round this one to 60 for easy calculation. Because in estimation, you don't need calculator. And then I round this one to 2 significant figure, I will have this one to be 200. So it's easy for me to multiply 200 as 60. 60 by 200. It's easy because I can just say 2 times 6, I get 12. 2 times 6, I get 12. And then I add all the number of zeros. There are 3 zeros altogether. 1, 2, 3. I add the 3 zeros, I get 12,000. You see, this is for estimation. So when they ask you to estimate, meaning you do each number first before you do the final calculation. Okay, this is for estimation. You estimate each number before you do the final calculation, before you multiply. This is estimation. Okay, it does not mean if you multiply, estimation does not mean it's the accurate answer. It means you are close to the real answer. You've estimated the real answer. Okay, you are saying that if someone multiplies 57 times 246, although the person is supposed to get something close to 12,000 or around 12,000, either below or a little bit above 12,000. That's what the person is supposed to get. But if someone can also get, okay, let's move on quickly. And now if you give you the root of 125, estimate root 120 times 48. They give you something like this, times 48. Times 48. This one, since it's estimation, you cannot find, you'll be getting decimal if you find the cube root of 120. So a number that is closer to 120 that you can get the cube root is 125. So I can simply say the cube root of 125, okay, of 125 multiplied by this number. I can round it up to 50. I can round it up to 48. Can be rounded up to to nearest whole number. This one will be 50. So the cube root of this is 5, right? The cube root of 125 is 5. So 5 times 50. 5 times 50. You get 250, right? Because 5 times 5 is 25. Then you put the 0 in front of it. So you get 250. Okay? You get 250. So, but this 250 is not the real answer. It's just an approximate answer. It's just what? An approximate answer. Okay? So now we go to the next one, which is called the upper bound and lower bound. We go to upper bound and lower bound, which is going to be the last section of today. Now, upper bound and lower bound of whole numbers. We start with UB, upper bound, UB, and lower bound. upper bound and lower bound. Now, for whole numbers, we start with whole numbers. Whole numbers is just plus minus 0.5. For whole numbers, we just plus minus 0.5 to the number in order to get the upper bound and lower bound of that number. Okay, for example, let's say we are given 5. They say find the upper bound of 5. Okay, if they ask us to find the upper bound of 5, let's say we are given 5. So what we do, every whole number, not only 5, whether they say 100, 1000, any whole number, 555, 774, any whole number, the trick is, if you want to find the upper bound, you say plus 0 point, you say plus 0.5, you add 0.5. Okay, you add the plus 0.5 to get the upper bound. And if you want to get the lower bound, you say minus 0.5. If you want to get the lower bound, you say minus 0.5. Okay, for all whole numbers, this is just this trick. This is just the trick. So for the upper bound, we get 5.5, because 5 plus 0.5, you get 5.5. So the upper bound is 5.5, and the lower bound will be 4.5. The lower bound will be 4.5 of this number. So if you draw an inequality for this, you see that we have this. If you draw an inequality for this number, here will be your upper bound, and this way will be your lower bound. This way will be your lower bound. So for all whole numbers, this is just what we do. It's as easy as that. Okay, it's as easy as that. All whole number, 32, for example. If you give you 32, what will you do? You add 0.5 to get the 0.5 to get the upper bound of 32, and you subtract 0.5 to get the lower bound of 32. It's as easy as that. Is that okay? So you don't have to. Sometimes the textbook makes it very complicated. Okay. Okay. So here you minus 0.5. You minus 0.5. So in the upper bound, we get 32.5 of this number. We get 32.5. And in the lower bound, we get 31.5. We get 31.5. Okay, so this is what it is. For all whole numbers, this is just what it is. Okay, the upper bound and lower bound. Now let's go for one place decimal. If you have one decimal place, 1 dp, a number with 1 dp, one decimal place, they ask you to find the upper bound and lower bound of one decimal place. Okay, for example, 4.5. They give you 4.5. They say you should find the upper bound of 4.5. It's already 1 dp, right? So since it's one decimal place, how do we find the upper bound? It's not going to be plus 0.5 anymore. So for this type of number, you're going to add the same addition, but you add plus 0.05. You say plus 0.05. That's what you do. Here, you say lower bound. For lower bound, LB, lower bound LB, upper bound UB, okay? UB. So for lower bound, you subtract, you say minus 0.05 for one place decimal, okay? For one place decimal. So if we add 0.05, what will we get? If you add it to this one, you get 4.55. So for the upper bound, we get 4.55. We get 4.55. If we add, take this number and add 4.5 plus 0.05, you get 4.55. Now, if you subtract this from this one, you get 4.45. You get 4.45 for the lower bound. Okay, so it's easy to get the lower bound. Now let's go to 2 place decimal. Okay, we are done with it's just the same for all numbers. Once it has 1 place decimal, you just add for upper bound 0.05. For lower bound, you subtract 0.05. Is that okay? Okay, now let's go to 2 decimal place numbers. 2 DP numbers, 2 decimal place numbers. Numbers like, for example, we have, let's say we take numbers like 4.55. Numbers like this, 4.55. Find the upper bound and lower bound. So to find the upper bound, UB, to find the upper bound, what should we do? Since it has 2 decimal place, it's a 2 decimal place number. Now to find the lower bound, what should we do? So if you look, it's same logic. It's same logic. Now, even logically, even without me saying it, you already know what you should do. You say plus 0.005. Now, if it's 2 decimal place, after the decimal point, that's the number of zeros you get before 5. Okay? If it's 2 decimal place number. So here, you say minus 0. After this point, you count. How many decimal place? 2. So you have to put 2 zeros before 5. 0, 0, 5. Now look at this one that was 1 decimal place. After the 0 point, after this point, decimal point, you must count only 1 0 before 5. The one that was whole number, there was no 0 before 5. You just say 0.5. Okay, that's the logic. So this one that is 2 decimal place, you count. After this first 0, don't count this one. You put point. After the decimal point, you count 2 0 before 5. So you go to add this one to this number. We will get for the upper bound 4.555. You get 4.555, right? So if you subtract this one, what will you get for the lower bound? We get 4 point. What do we get? If you subtract, you say 4.55 minus 0.005. What do you get? What do you get? 4.55 minus 0.0. You get 4.545, right? 545. Check. Okay, finish this one up. You get 4.545, right? That's what you get. So if you do this one. So this is all for upper bound and lower bound. Now, the application. How we do it for plus, multiplication, division is what matters. For division, in the exam, what Cambridge will give you is quite different. If they ask you to multiply, upper bound is easy. Let's say, for example, 34. You say multiply 34, find the upper bound of the product of 65 and 34. You don't just say, oh, 34 times 65, then you find the upper bound and lower bound of the answer. No, you have to find the upper bound and lower bound of each of these numbers. What's the lower bound of 34? You get 33.5. 33.5. That's the lower bound of 34. What's the upper bound of 34? You get 34.5. You get 34.5 because you add 0.5. You get 34.5. Okay? So have we done this? Then you do for 65 also. We have to do for 65 as well. Right? Now let's do for 65. What's the upper bound and lower bound of 65? The lower bound of 65 is 64.5. 64.5. That's the lower bound. 64.5. And the upper bound will be 65.5. The upper bound will be 65.5. Now for multiplication, because they say we should multiply, right? Multiply this by this. For multiplication and addition, same way. After you break each number down, each one to upper bound and lower bound, you go to multiply the lower bound of this with the lower bound of this one for multiplication. But if it's division, we go to divide the upper bound of the highest one by the lower bound of the lowest one. For division, it's quite different. Okay? But for multiplication, you just multiply lower by lower. Lower of this one by lower of this one, you multiply them. Lower of this one by lower of this one, and the upper of this one by the upper of this one. Multiply the upper of this by the upper of this one for multiplication. So multiply this by this, the upper by this upper. You multiply them. Multiply. And then the lower, multiply the lower by the lower. Multiply this lower by the lower. Multiply this lower bound by this lower bound for multiplication. And the same way, the same thing apply to addition. You add lower to lower for addition and upper to upper. So the lower bound is 33.5 times 64.5. You get 2,160 points. Okay, so for lower bound, if you are looking for the lower bound answer, you will multiply 33.5, 33.5 multiplied by 64.5. Multiply by 64. Multiply by 64.5. And this one will give us an answer. This one will give us an answer, which is 2160.75. 2160.75. 60.75. Okay, this will be the lower bound of the calculation. This will be the lower bound of the calculation. Okay, now for upper bound, for upper bound of the calculation, we will get UB. For upper bound of this calculation, we get 34.5 times 65.5. 34.5 times 65.5. So when you do this, you get a number such as 2259.75. 2259.75. This is the number you get for upper bound. Is that okay? So I presume this is very understandable. Now what if we are asked to do this division? 33.3 divided by, after this I think we'll be done with upper bound and lower bound. So question number 3, let's say this is our question number 3. Let's say this multiplication was question number 2. This one. Okay? Let's quickly go through this and then we end our class so that it will not be too long. Now we say 33.5 divide 33.5 over 22.0. Okay, you can see this is not just 22, it's 22.0. So it's one place decimal, right? One decimal place. So we're going to have, we're going to add 0.05 and subtract 0.05. It's not just 22. You must take note of this. So what we do, let's write the upper bound and lower bound. Let me use X. Okay, I'll write the upper bound of this number, meaning the upper bound we always say is lesser than that number. 33.5, we're going to add 0.005, 0.05, since it's one decimal place. So we will get 33.55 for the upper bound. We'll get 33.55 for the upper bound. And then lower bound is lesser than or equal to, greater than or equal to that number. This will be 33.45. This one will be 33.45. This will be the lower bound of this number. Okay, every number they give you, you use X and use the inequality for it. Okay, then what is the upper bound of 22.0? Not just 22, it's not a whole number. 22.0 is one place decimal. So you go to add 0.05 to get the upper bound. So you always say it's lesser than that number. It will be 22.05. If you add 0.05, it will be 22.05 as the upper bound. Okay, and then for the lower bound, you will get 21.95 because you subtract 0.05 away from 22.0. you get 21.95. You get 21.95 if you do that. So now the trick for division, which is different, what I said before, when you are doing division, if you want upper bound, you take upper of the upper level of the numerator, the upper of the numerator, divide by the lower of the denominator. Please pay attention. If you want UB, upper bound, if you want UB, the upper bound, if you want UB, okay, you're going to take the upper of the numerator, divide by the lower of the denominator. So meaning like this, we're going to do it like this. We're going to divide 33.5. We're going to divide it by 21. So it's like you are dividing upper of the numerator, the upper bound of the numerator. You are dividing it by the lower bound of the denominator. Okay, please pay attention. This is the difference between division and multiplication. Multiplication is lower times lower and upper times upper. But division is upper of the, if you're looking for upper bound, you say upper of the, so which means if we're looking for upper bound, we say the upper of the numerator, UB of numerator, so this N I'm writing means numerator, over the LB of denominator, LB over the LB of the denominator. So I write this subscript D means denominator. So that will give us 33.5 divided by 21. What do we get? Divide by 21.95. 33.5. Was it 0.5 or 0.55? Sorry, it was 0.55. 33.55 divided by 29.95. 21.95. So what do we get when we do this division? When we do this division, we get 1.120. We can say 1.120 or 1.12. Okay? We get 1.12. Okay? We get 1.12. Okay, 1.52. Okay, we pressed wrong thing in the calculator. 1.523 or 52, whatever you get. 1.5. Okay, this one we can 1.52. Okay, maybe approximately 1.53 because 528 something. So we can approximate to 1.53. Okay, we can approximate this one to 1.53 to nearest two decimal places. Okay, so this will be our upper bound. Now, how do you do the lower bound? The lower bound, you come here, you say LB, the lower bound. You divide the lower of the numerator by the upper of the denominator. You divide the lower of the numerator, divided by the upper of the denominator. So what's the lower of the numerator? The lower is 33.45, right? So this one you say, you divide, if you're looking for lower bound, you say the lower bound of the numerator, divide by the upper bound of the denominator. Divide, so that we can get the most lower. We can get the most lower. Okay? So this gives us 33.45 divide by the upper of the denominator, which is 22.05, which is divide by 22.05. Okay, this one will give us 0.05. Okay, sorry, my writing is quack. Okay, this becomes 1.52. Okay, if you approximate to the nearest two decimal place, 1.52. So this one you get 1.52 for the lower bound, and upper bound you get 1.53. Okay, so this is what it is. So with this, we've come to the end of our today's class. Thank you for joining us.